Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be taking a look at TopTechBoy's Raspberry Pi class, lesson number 25, and also lesson 25. If you remember in lesson 25, Paul took a look at the DHT11 temperature sensor, and in lesson 25, Paul took a look at the LCD1602 character array. Okay, I had to have a little fun with Paul for accidentally duplicating the lesson numbers. When you have an excellent teacher who doesn't make a lot of mistakes, his mistakes show up pretty easily, and it's kind of fun to enjoy those. But the nice thing about it is both lessons actually go hand in hand. The homework is worked together, so it's not really a big deal. It's just kind of a funny little thing that happened. Before I get too far down the road, I do want to mention I am behind on my homework by a few weeks, and so I've jumped from lesson number 20 to lesson number 25. I'm not going to skip 21 and 24. I'm going to come back to those, but the reason I wanted to go to 25 first is I wanted to go through the LCD array, and I also want to look at lesson 26 here in the short while, and look at the piezo's as well, because if we have some additional items, it's going to make lessons 21 through 24 even more fun. So I thought, let's just do them a little bit out of order since I have the ability to do that since I'm behind. And we'll have even more fun with the ultrasonic sensor and the PIR sensor when we get that far. So let's turn our attention to these LCD screens. So if you're familiar with the LCDs, these are LCD1602s. This is the type that would normally come in like the Arduino starter kit. And this is basically just a parallel output device. So we have 16 pins, and we have 8 of them are data. So we actually send a full byte of data every time we send data to the LCD unit from the Arduino. So several years ago, I was working with these on Arduino and having some fun with those. Well, then I was rummaging through one of my parts box, and I found a couple of these, and these are 20 by 4 character arrays. And I thought, well, if I can do a 16 by 2 on an Arduino, I can certainly do a 20 by 4. And so I looked up the data sheet and discovered that the 16 pins on the 20 by 4 are in fact identical to the 16 by 2. And the only difference is when you initialize the library in Arduino, you define the dimensions of the LED array or the LCD array. So instead of defining 16 by 2, define 20 by 4 and start printing data, and it works pretty much the same way. What came in the Raspberry Pi kit, however, is a little bit different. We have this little adapter that's actually been soldered. If you look at the front of the 1602, you can see it's got the 16 pins. So it's accepting data, 8 bits of parallel data. But what's happened is that the manufacturer has soldered a adapter on it that is going to, instead of sending it 8 bits of parallel data, it's going to send it 8 bits of serial data through the I2C bus. Now let me see if I can orient that a little better. There we go. And of course on here we have the potentiometer for the contrast, the wiring for the backlight LED, and so forth. And of course the big advantage with these is we're only going to run 2 wires to the microcontroller instead of what is it, 7 or 8 with the Arduino. So this makes it a little easier to connect. But then I was thinking, well, wait a second, if this is just a standard parallel board with an I2C serial to parallel adapter, can I transpose this serial adapter to the 20 by 4? And the answer to that is, I don't know, but I'm going to find out, because I actually was able to locate some of these I2C adapters, and I have a few that are on order on a delivery truck somewhere. Hopefully they come to my house soon. So I can try soldering these onto the 20 by 4 arrays and see if I can use a 20 by 4 array with the Raspberry Pi in the same way that we're using the serial I2C version of the 1602. Before I go too far, if you are interested in knowing more about how these LCD arrays work, I'm going to link down below to a video series from David Murray, otherwise known as the 8-Bit Guy. And he did a 3-part series on really digging into the weeds on how these arrays work. And one of the things he did is he actually proved that you can write data to it without using a microcontroller. He built a little box with some toggle switches to mimic a parallel binary signal, and was actually able to move the cursor and write data and do some fun things. So if you really want to dig into how these work, he did a fantastic job, and I'm not going to take any more time of that because I want to get to the lesson. So what I have in front of me here is I have a DHT11 temperature sensor and an LCD1602. This is the I2C serial version, and these are mounted to a little 3D printed box that I made. And I've got my wiring, I've got power and data. Now I've got these going back to the breadboard because I've got a 10K resistor here. This is a pull down resistor on the data input. And then that goes to a GPIO pin on the Raspberry Pi. And then I've got you can't see them because they're underneath, but I've got my 4 wires going to the LCD. No, I'm sorry, that's the wrong one. There's my 4 wires going to the LCD. I've got 2 going to my 5-volt rail on the back side of the board, and then I've got the data pins going to the GPIO 3 and 5, which are the I2C pins on the Raspberry Pi. I do apologize for the mess in the wiring. One of the problems that I run into when I have devices that have the male pins, and then I'm going into the male pins on the Raspberry Pi, is that there's no good way to make custom female jumpers that are the right length. So I'm at the mercy of whatever I have in my box. And unfortunately, what I end up doing is taking the longer ones, putting a knot in them. So you can see I kind of tied the temperature sensor ones together and the LCD ones together to try to minimize the clutter. But there's just no way to get a clean connection when I'm actually connecting these male pins, because then I need that female DuPont connector, and they're kind of a pain to work with. So there's no good way to make a jumper. So now that we've looked at the hardware, let's take a look at the program. And I'm hoping that my camera is going to behave. I'm using a lamp next to the LCD because it's throwing off the white balance of the camera. And if I throw it off enough, then the camera can see the array. The problem is the backlight is too bright for the camera. There we go. So there's my little splash screen, Simply Brian Enterprises, and there's the introduction to the lesson, what we're doing. And now we can see we are reading the temperature from the DHT11 sensor and displaying it on the LCD, as well as the humidity. And what we're going to do is we're going to press this button here, and we're going to switch, and we're going to see it go to mode. So now we're going to measuring in Fahrenheit. And thank you, Charlotte, for the idea. We're also going to measure in Kelvin. And let's flip back to Fahrenheit here. And now I'm going to just kind of put my thumb on this here. Oh, I lost my my light. There we go. And you can see, for some reason, the humidity rises when I put my finger on it before the temperature, but I don't really know why, but that's what it does. But you can see it's obviously affecting the temperature. It's increasing temperature, it's increasing humidity. And now I'm going to take my thumb off of it, and we see it drop down pretty quickly. I don't know if you can really tell, but when I'm switching between modes, there we go. Now you just saw it. It took some time for it to switch between modes, and I was trying to figure out why that was, because I'm doing the time.monotonic loops so that I'm not stopping my code. There's no sleeps in the read or write to the LCD. So what's going on there? And I'll show you when I get to the code what I found. But first, we're going to exit the program. So we can't call it the cat talk button anymore. So I decided to go old school and do a little press your luck button here. So we're gonna go big money, big money, big money. Oh, big money. Pool table, pool table, pool table, pool table, pool table. Yeah, the pool table. No whammies, no whammies, no whammies. Oh no, whammies. And the program ends. So thanks for bearing with me with that. All right, let's take a look at the code and we can walk through this here. All right, so as we're adding components and as we're adding libraries and so forth, this section of my code is getting longer. I'm putting all these comments up here about all the things I'm doing. This is so that if I either want to clone my projects folder to another Pi, or if I have to rebuild my Pi, if the SD card crashes, something like that, I remember all the steps that I did to make all of these components work. And so I'm bringing in the DHT11 library and the LCD1602 libraries, and we're setting up our modes, we're setting up our pins, and here we're just setting up our DHT11. So I'm creating the DHT11 object, creating the LCD1602 object, and this is where I'm initializing 27 is the address of the I2C adapter for the LCD. I found out, see if I can dig this up quick here. Yeah, let's drop over here quick. So there are on here, there are these 3 sets of solder pads, and you can set the address of the I2C. You set the I2C address for this device by connecting these, and if they're all open, it's address 27. Um, just a neat little piece of information that I accidentally learned, but that's why it's always 27 when you list the I2C devices, because most of the time those pins are not going to be jumpered. Then I've got, these are all my monotonic counters and statuses and everything. And then I actually come in here, start the program. I do my little splash screen. I print my Simply Brian Enterprises, lesson information. I do have sleeps here, but that's just so that they slow down enough you can read them. We're not in the loop yet. And then we're going to do our monotonic, and we're going to do a temp delay. So this is 200 milliseconds. So we're only going to check the temperature every 200 milliseconds. And every 200 milliseconds, we're going to come through here, decide what mode are we in, and then we're going to set up our string, write it out. Actually, sorry, I skipped a line. This is the DHT read. This is the important one. So we come in here every 200 milliseconds. We do a read from the DHT, and then we interpret, is it going to be Celsius, Fahrenheit, or Kelvin? We put our string together. We always calculate humidity, and then we write it out and reset the timer. Here is our code to switch modes. So normal state is, because this is a pull up button, normal state is true. So we're going to be true if, because we have a value, we have a pin value, and we have a mode. So when the value changes here, it's going to set the pin value. So when they mismatch, pin value versus the pin value versus the mode value, we're going to rewrite it, and that's what actually changes the mode. So when we get up here, it knows which mode to use. Let's see here. Otherwise, it doesn't do anything, because if it doesn't have, if the value of the button is true and mode pin val and the mode are the same, then nothing changed, and we just keep going. Here we actually go through, determine the changes. I found the best way to do this is with if, else, if, and else when you're doing 3, because if you're doing 2, you can do an if and else, but if you're doing more than 2, then you need to do else ifs. That's to keep it, because otherwise, if I did like nested ifs, it would change the value and then it would trigger on the next if. So it would basically always end up the same by the time it ended up through the else clauses. So if, else, if, and else seem to be the best way to do that. And then if we get down here, that basically means we're not doing anything, so we just reset the counter. And then we do something similar for press your luck. So I'm coming down here, and if my luck counter is 0, I'm going to increment it by 1. I'm going to big money, and then do increment to 1. Otherwise, if it's 1, pool table, increment to 2, and then we increment to 3, and then we actually escape the loop. So that's what's going on there, and I'm going to walk through here. And then when I get to the end, we just do a clear, to clear the temperature stuff off the screen. Oh no, whammy, give us a sleep to read that, and then we clear. So one thing I saw that's very important is that these arrays always remember what was written to them last. So it's important when you start your program and when you end your program to clear the array. Otherwise, whatever's written on here is going to stay there until you run the program again. And then, of course, we do the cleanup. So hope you enjoyed the silliness. Hope you enjoyed the fun of that program. Um, oh, you know what? I forgot to talk about something that's actually important. So you noticed that in the one case, when I hit the button and changed the mode, it took some time to register. And I had to really dig through the code to figure out why, because I was looking at this and I was doing, I'm doing monotonic. I don't have sleeps in these loops, so what's going on here? And what I discovered is that in the DHT11 read function, so here I have the DHT11 library pulled up, when it does the read, it's putting sleeps in here because it has to wait for the DHT11 to respond. It sends a high, waits, and then sends a low. And here's a 50 millisecond sleep. Here's a 20 millisecond sleep. So every time you do a DHT11 read call, it's actually sleeping for 70 milliseconds. And so that was really throwing my code off. And so I was trying to think of ways around that. Um, One way would be to come in here and set my delay time longer so that instead of 200 milliseconds, I'm doing something like 500 milliseconds, so I'm not reading it as often. But then I also don't update the display as frequently, and I didn't like that. I wanted it to be somewhat instant, especially when I put my finger on it. I wanted it to update quickly. The other way to do it, though, that we'll explore in future lessons is all the programs that we've written up to this point are what we would call single-threaded. So we just come through here, run this line, run this line, run this line, run this line, run, 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 run. Oh, we get a while loop. Okay, now we're going to loop through that. And we're going to do a 4, and then we're going to come back up out of that 4 when we're done, those kind of things. So, but it's always one instruction at a time. We can do in Python, we can actually make use of threading. So we can actually launch a separate thread that's doing other things while this code is running. So in a future lesson, because it's a little over my head right now, we're not quite there yet. What I would do is I would actually start a thread to read the DHT, and basically that thread is just going to run, read it, run, read it, run, read it, just do that over and over and over and over and over. And then we would have to take advantage of a class to be able to send that data from the DHT11 read thread into our main thread where we're actually going to read the temperature. So in that case, I'm at the liberty of setting my temperature read value to whatever I want, however frequently I want to read it. There's always going to be data in that class, regardless of what that DHT11 thread is doing. And I then have the ability to control that. And then I don't get that lag when I press the button and wait for it to switch modes on the screen. So anyway, that was kind of a neat rat hole that I ended up going down, trying to figure out why my code was doing that. And I look forward to future lessons being able to do some more complex things like that. But like I said, today it's a little over my head. If you like this video, be sure to hit like and subscribe below. I also want to make a point that I'm starting to post my videos both on YouTube and on Rumble, and I'll have more on that in an upcoming video. But for now, I'm Brian from Simply Brian Enterprises. Thank you for watching, and I'll see you next time.